No, good morning, children. Now we'll continue with the problems. Again, the problems are based on the standard limits. Now we'll do some problems based on this limit, this standard limit, extending to a of x power n minus a power n. So here you must understand that the x tending to a. So the same x should be here and same a should be here. Whatever you are writing here, that should be here and here. And these powers should be same, like that. Okay, so now the sum is x tending to 0 of. So here the power is 1 by 8. So observe how we are reducing it to that form. So what we do is, because we have 1 plus x, we'll write 1 plus x tends to 1, like that. So 1 plus x whole to the power 1 by 8. Now as x tends to 1, 0, as x tends to 0, x plus 1 tends to 0 plus 1. 0 plus 1, that is 1. So x plus 1 tends to 1. X plus 1 tends to 1. Now we have 1 minus x. So that we'll see how we can change. So as x tends to 0, minus x tends to minus 0, that is 0 only. So that means add 1 on both sides. So minus, when you are multiplying by minus 1 into x tends to minus 1 into 0, that is 0. So now add 1 on both sides because you have 1 minus x. 1 minus x tends to 1 plus 0. So that is 1. So that means 1 minus x tends to 1. So we need those two now. So we'll subtract 1 and add 1 so that we'll reduce it to the standard form. X tends to, this is our x tending to a. A here is 1. So that a is missing here. That a is missing. You have x power n minus a power n. This is our x and this is our a. A1 is missing. So we'll add and subtract 1. So subtract 1, add 1, and then this minus of will be there as it is by x. Now, okay, I'll draw a line so that we'll not get confused with the steps. So this is limit x tending to 0 of 1 plus x whole to the power 1 by 8 minus 1, and this will write as minus of 1 minus x whole power 1 by 8 minus 1. So it should be in the form x power n minus a power n by x. Now what we do is, we'll write separately, divide this separately by x and this also by x, and limit also we'll write separately. So it is equal to limit x tending to 0 of 1 plus x whole to the power 1 by 8. This 1 also will write as 1 power 1 by 8, so that it is in the form x power n minus a power n by x. This also will change x to x minus a. Okay, okay, we'll write limit x tending to 0 of 1 plus x whole to the power 1 by 8 minus 1 power 1 by 8 by x, like this. So we divided two steps, we combined here. So what we did, we divided this separately by x and this separately by x, and then we wrote the limit for this term and this term separately here. Now what we do, we have this is 1 minus x. So what we do is, we'll bring this minus sign here. In the next step we'll do that. So it's equal to limit. Now here we'll change because we have 1 plus x. So 1 plus x tends to 1 of 1 plus x whole to the power 1 by 8 minus 1 power 1 by 8 by x. For this x will add 1 and subtract 1. Add 1 and subtract 1, so that it is in the form x power n minus a power n by x minus a. So we'll put brackets for this minus. This minus will bring down here and we'll write plus limit x tending to 0 of 1 minus x whole to the power 1 by 8 minus 1 power 1 by 8 by minus x. After bringing minus 1 here, or multiply by minus 1, whatever, multiply and divide. Now add 1 and subtract 1 so that it is in that standard form. Now for this we can write the limit. For this we can write the limit as, what is the limit? It is in the form limit x tending to a of x to the power n minus a power n by x minus a. So it is n into a to the power n into a to the power n minus 1. And then plus, we'll write here in the standard form. As x tends to 0, we have 1 minus x also tends to 1. So this is 1 minus x whole to the power 1 by 8 minus 1 power 1 by 8. Now add and subtract 1 so that it is in the standard form. And so this is 1 by 8 only. 1 power number is 1 by 1 only. This is 1 power 1 by 8 minus 1 means minus 7 by 8. It is equal to 1. And here again it is in the standard form. So n into a to the power n minus 1. So this is also 1 by 8. So it is equal to 1 by 8 plus 1 by 8. That is 2 by 8. That is 1 by 4. So this is your answer. So like this we have to do. Understand the steps properly. See how we are doing. We are reducing it to the standard form. So first you understand this. We have to get it in this form. 1 plus x, 1 minus x, how we are doing there. And then add and subtract 1. Split the limits. And then do this problem. Okay, now next problem. Limit x tending to a of, next second problem. This is again very important. Second problem. Limit x tending to a of root of a plus 2x minus root 3x by root of 3a plus x minus 2 root x. Here both numerator and denominator have irrational numbers. So when you substitute a, this again becomes 0 by 0 form. So what you have to do is, you must rationalize numerator and also the denominator. Both numerator and denominator should be rationalized. Then it is easy to simplify. Root a plus 2x minus root 3x. Yes. So multiply and divide this by root of a plus 2x plus root 3x. Okay, now by this is root of 3a plus x minus 2 root x. Okay, multiply. First I am rationalizing this. So root of a plus 2x plus root of 3x. So we are first rationalizing the numerator. Then what is it? It is in the form a plus b into a minus b. So a square minus b square. What a, when you square it, the square root will go. Okay, so it is equal to a minus b into a plus b. A square minus b square. So limit x tending to a of a square means a plus 2x minus b square means minus 3x. Okay, by root of 3a plus x minus 2 root x. Okay, this will be there as it is. Root of a plus 2x plus root 3x. Now this should again, see, when you put x as a, this becomes 0 by 0 form only. Now again rationalize this. What is the rationalizing factor? Plus. So I will write here only into root of 3a plus x plus 2 root x by root of 3a plus x plus 2 root x. So if you take these two numbers, this is in the form a minus b, a plus b, a minus b into a plus b, a square minus b square. So limit x tending to a of, now we'll simplify this, a minus x by, okay, these two we are writing as 3a minus plus x minus b square means 4x. Now we'll write these two as it is, into root of 3a plus x plus 2 root x by root of a plus 2x plus root of 3x. Okay, now when you simplify this, this is 3a minus 3x. So take 3 common. So limit x tending to a of a minus x by 3a minus 3x will write as 3 into a minus x into again this root of 3a plus x plus 2 root x by root of a plus 2x plus root of 3x. Now a minus x gets cancelled. You can just substitute the limit. So when you substitute x as equal to a, this is 1 by 3. So the limit is 1 by 3 into, now substitute, put x as equal to a. 1 by 3 into root of 3a plus a plus 2 root a by root of a plus 2a plus root of 3a. Root of 3a. So this is root 4a plus 2 root a. So it is equal to 1 by 3 into root 4a. Root 4a plus 2 root a by, this is root 3a plus root 3a. Root 3a plus root 3a. So when you simplify, it is 1 by 3 into, this is root 4a is what? Root 4a is root 4 into root a. That is 2 root a. Similarly, root of 3a can be written as root 3 into root a. Root 3 into root a. So this is 2a plus 2 root a plus 2 root a by 2 times root of 3a. 2 times root of 3. So it is 1 by 3 into 4 root a by 2 into root 3 into root a. So root a gets cancelled. 2 2s are 4. So it is 2 by 3. So the answer 2 by 3 root 3. 2 2s 4, 3 root 3. So 2 by 3 root 3. So the answer is 2 by 3 root 3. This is the answer. So simplify properly. So it is 2 by 3 root 3. Yes. So rationalize both numerator and denominator. You can easily understand. The next problem, third problem. Again, this is very lengthy. All these are very, very important. Okay, next third problem. Limit x tending to a of sine of x minus a into tan square of x minus a by x square minus a square whole square. X square minus a square whole square. So we know x square minus a square. We have x minus a here. So x square minus a square will write as x minus a into x plus a. Again that whole square is there. So we'll split it and we'll do like this. Okay, first I'll write this. X square minus a square can be written as x plus a into x minus a. Now he has given whole square. So x square minus a square whole square will become x plus a whole square into x minus a whole square. Into x minus a whole square. Now we'll see how we'll convert this tan square theta. Tan square theta can be written as sine square theta by cos square theta. So we'll write that also. Okay, now x minus a we will take as t otherwise. Okay, put, because it is x minus a here, x minus a here, we'll take x minus a, I will write here so that I'll continue. Put x minus a is equal to y. Then it means x is equal to a plus y. So x tends to a implies x minus a tends to 0. So that means y tends to 0. Y tends to 0. Now we'll write in terms of y. Limit y tending to 0 of sine y into tan square y by, okay, this x square minus a square is what? X plus a whole square into x minus a whole square. So x plus a means y square. X minus a is x minus a is y, x plus a. So what is x plus a? X is a plus y. So a plus y plus a, that is 2a plus y. So 2a plus y whole square into y square will write. Okay, now x square minus a square whole square I simplified here. So we'll write it as 2a plus y whole square, 2a plus y whole square into y square. Okay, now we'll convert tan square y to sin and cos. So sin y into sin square y by cos square y by 2a plus y. 2a plus y whole square into y square. So x plus a, x is this, x plus a is 2a plus y. 2a plus y whole square into y square. Okay, so it is equal to limit y tending to 0 of sin cube y by cos square y into 2a plus y whole square into y square. Now we have sin cube y. When we have sin cube y, we should have y cube in the denominator. So what we'll do, we'll multiply and divide by y so that it is in the standard form. So we'll write limit y tending to 0 of sin cube y by y cube, y square into y cube. Rest we'll write separately, y by cos square y into 2a plus y whole square. Now we'll write the limits separately. So limit y tending to, because it is in the standard form, we'll write sin y by y whole cube, sin y by y whole cube like this, into limit y tending to 0 of y by cos square y into 2a plus y whole square. 2a plus y whole square. Now you can see this limit is 1 cube. So it is equal to 1 cube into, now substitute y as 0. This is not indeterminate. You see it is 1 cube into 0 by, what is cos square 0? Cos 0 is 1. Cos square 0 into 2a plus 0 whole square. Cos 0 is 1. So 1 into 0 by 1 square into 2a whole square. That is 4a square. So denominator is not 0. So it is 0 by any number is 0. So the answer is 0. So like this, it is not indeterminate. Just to simplify x square minus a square simplification, you try to understand. That's all. Okay, next problem. Next, fourth problem. Fourth problem, limit x tending to 0 of secant x minus 1 by x square. So here secant x will convert to cos. So 1 by cos x minus 1 by x square. So it is limit x tending to 0 of 1 minus cos x by cos x into x square. 1 minus cos x, you know, 1 minus cos x is 2 sin square x by 2. 1 minus cos x is 2 sin square x by 2. So it is limit x tending to 0 of 2 sin square x by 2. It is from trigonometry. This x square will write here and then cos x. Now we have x sin x by 2. X square, sin square is there. So we should have x by 2 whole square. X square is there. By 4 into 4 you should have. So multiply and divide by 4. So it is 2 into sin of x by 2 by x square. Sin square I'll write otherwise. By x square by 4 into 4 I'll write into 1 by cos x, so that it is reduced to the standard form. Now this is in the standard form. Rest will write separately. So it is limit x tending to 0 of sin of x by 2 by x by 2 whole square into 2 by 4 cos x. Now this also we should change. Now we'll write the limit for this separately and for this separately, and then we will find the standard. We'll write the standard limit value. So it is equal to limit x by 2 tending to 0 of sin of x by 2 by x by 2 whole square into limit x tending to 0 of This is 1 by 2 cos x. So this limit is 1 square and this limit is 1 by 2 cos 0. Cos 0 is 1. So it is 1 by 2. So the answer is 1 by 2. So like this we do. Okay. Now next problem. Limit. Similar problem we do next, fifth problem. Limit x tending to, this is very important problem, x into e power x minus 1 by 1 minus cos x. Okay, now e power x minus 1 is there, so we should have an x here. E power x minus 1 by x limit is 1. So 1 minus cos x, we have seen 1 minus cos x is 2 sin square x by 2. So these two things you have to do here. So limit x tending to 0 of x into e to the power x minus 1. First we'll write by x into x by, and then 1 minus cos x will write as 2 sin square of x by 2. Okay, this limit we'll write separately. So it is limit x tending to 0 of e power x minus 1 by x into x square by, this we are writing here, x into x square by 2 sin square x by 2 we are writing separately. Okay, now this limit, we'll write the limits separately now. The first one separate limit into second one separate limit we'll write. So it is equal to limit e power x minus 1 by x as x tends to 0 into limit x tending to 0 of x square by 2 sin square x by 2. 2 sin square x by 2. So, okay, this limit is 1. Now, this we should reduce to the standard form. So, limit x tending to 0 of, see how we are reducing it to the standard form. Sin square of x by 2 by x square. This x square will bring down here. X square. So, what should we have? Sin of x by 2 whole square. So, x by 2 whole square should be there here. So, we'll write 1 into anyhow it is 1. So, limit x tending to 0. So, x by 2 also tends to 0. As x tends to 0, x by 2 also tends to 0. So, 1 by 2 into sin x by 2 whole square. So, we should have x by 2 whole square. X square by 4 into 4 will do. So, that it becomes 1 by, I can write this limit down here. So, limit x by 2 tending to 0 of 1 by, okay, 2 into sin x by 2 by x by 2 whole square. Sin x by 2 by x by 2 whole square into 1 by 4 is there, into 1 by 4. So now what is this 4 actually goes to the numerator, or otherwise I'll write 1 by, this limit is 1. So 2 into 1 square into 1 by 4. This limit is, so it is 1 by 2, and when it goes to the numerator it is 2. So the answer is 2, like this. Or else instead of doing all this, you could have also taken like this. Instead of bringing x square to the denominator, you can also use sin x by x. Limit as x tending to 0 of sin x by x is 1, no? So this also implies that limit x tending to 0 of x by sin x is also equal to 1. Because you can take x to the denominator and do like this. So here itself you could have done multiply and divide by 4 and you can get the answer. So you can do like this. Okay, this problem is very important. Okay, if you are using this formula, then you need not bring it down, bring the limit to the denominator and okay, next problem. Next it is problem number, missed the problem number. Okay, next problem, limit x tending to 0 of log of 1 plus x cube by sin cube x. So here again we have the standard limit. What is the standard limit? Limit x tending to 0 of log of 1 plus x cube. 1 plus x cube by x. 1 plus x by x. So we have the standard limit. 1 is equal to 1. This is the standard limit. So in the place of x, you have x cube. So after this problem, we'll take down the homework. So instead of x, we have x cube. So we'll write limit x tending to 0 of log of 1 plus x cube is there. No? So we'll divide by x cube and then multiply by x cube and then sine cube x. So now we can write limit x tending to 0 of log of 1 plus x cube. See here, base is e. When base is not mentioned in calculus, when base is not mentioned, you have to take it as e. It is understood. So x cube into, I'll write limit x tending to 0 of x cube by sine cube x. Now as I said, sine x tends to x by sine x also is equal to 1. So it is in that form, you can see, and you can write this like this. Limit x cube tending to 0 of log of 1 plus x cube by x cube. Now it is in this standard limit. So this is the standard limit. Okay, into this we'll write as limit x tending to 0 of x by sine x whole cube. As I said, limit x tending to 0 of sine x by x is 1 or x by sine x is also equal to 1, because you can take this to the denominator and limit also to the denominator, and so it is equal to, this is 1, that is also 1. So like this we do. Okay, next problem number I missed. You can write down the problem number. I can take down the homework. Yes, this is the homework. See, in all these problems, it is compute. I didn't write any question there. Any limit is there, it means you find the limit or compute the limit or evaluate the limit. So here compute these limits. This we did now 1 plus x whole power 1 by 8 problem we solved. 1 by 3 problem is actually very important and you can easily do because we already solved that problem. This you can write x minus 3 into x plus 3 and then rationalize and you can do. Okay. Now this problem actually you can also do like this. 1 plus x whole power 1 by 3 minus 1 minus x whole power 1 by 3. So this is in the form. Okay, this you can also rationalize. This is like a minus b. Multiply and divide by, you have this formula. A minus b into a square plus ab plus b square is equal to a cube minus b cube. You can use this formula also in this case. You need not use the standard form. So you can multiply and divide by 1 plus x whole to the power 1 plus, okay, you can multiply by 1 plus x whole to the whole square whole to the power 2 by 3 plus a is 1 plus x whole to the power 1 by 3 into 1 minus x whole to the power 1 by 3 and then plus b square. B square means this 1 plus 1 minus x whole to the power 2 by 3. So you can multiply and divide like this. 1 plus x whole to the power 2 by 3 plus, okay, so write the same things here. So it is limit x tending to 0 of, okay. Now this is in the form a minus b into a square plus ab plus b square like that. So you can write limit x tending to 0 of a minus a cube minus b cube. A cube means 1 plus x. A cube minus b cube means 1 minus x by x into, you will write all this factor, all this you will write here. So you can see minus 1 plus 1 gets cancelled, 2x x gets cancelled. You can try this method. 2 gets cancelled, x gets cancelled. So 2 by, when you substitute x as 0, you will get 3, 2 by 3. So this way also you can do. Okay, in the next period, we'll continue with infinite limits and then left hand limit, right hand limit. Another 2 periods will complete this chapter.